Hi everyone, and welcome to my talk today about dromaeosaur evolution, looking at the claws and jaws of these famous raptor dinosaurs which we all know and love. Join me as I discuss which one was more influential into the evolution of this group. Dromaeosauridae are our raptors. Eudromaeosaurs, or true dromaeosaurs, are what we call true raptors and are what you think about typically when you think about the raptor dinosaurs. Here is the Velociraptor blue from the Jurassic World franchise. However, this isn't exactly how Velociraptor really looked. The true form of Velociraptor was a long-snouted, small-bodied dromaeosaur from Mongolia. The Velociraptor from the Jurassic World series was largely based on Deinonychus from Montana, which was quite a bit larger than the Velociraptor specimen, but still a little bit smaller than its movie counterpart. The raptor appearance also wasn't scaly skin and very lizard-like. It was a lot more bird-like in its posture, its position of its arms, but also in the fact that it and its relatives also possessed feathers. Although we don't have direct evidence of feathers in terms of preservation for Velociraptor, we do have quill knobs along its ulna, which suggests that it had large feathers on its wrists, similar to other raptors and birds today. That means we have more of a fluffier look to Velociraptor than the lizardy, scaly behemoth from the Jurassic World series. Raptors had an impressive predatory arsenal, including the famous Raptorial Claw of the second digit of their foot. This claw was held elevated or retracted similar to modern cats. Exquisitely preserved specimens like the Sarnotholestinae from the University of Alberta show they also had a preserved keratinous sheath, much like modern cats, but no one to cut their nails. Their hand claws were much more recurved and rounded along the leading edge, suggesting they were better at gripping rather than slashing or slicing. Their snouts were also filled with large serrated teeth, much like similar dinosaurs like tyrannosaurs or allosaurs, suggesting their mouths were very useful in acquiring prey and eating meat. Uses of the claw range between a gripping function from the highly recurved ones of like Dinonicus. Physical tests using this claw morphology actually showed the same thing, that it was quite good at gripping the flesh but not so much cutting it. A further study by Fowler in 2011 showed the very same thing, that they had quite the range of motion and would have been very effective at gripping. However, comparing to claws like Sarnotholestinae, which are much less recurved and sharper along the leading edge, it's more likely these would have been used for slashing. This is evidenced by the Velociraptor specimen in the fighting dinosaurs, which is shown to use its claws almost like a stabbing or slicing tool into the throat of this Protoceratops. The snouts were a little bit more simple and complex at the same time. It's thought that they use a basic sort of bite and rip form of feeding based on microwear on the teeth. Other tests that have been done have used simulations to show the responses of the skulls under biting and tearing forces and support the idea that this is the primary function of their jaws. Similar tests have been done on modern canids or dogs and shown that they specialize diets into small prey specialists, generalists, and large prey specialists with long, thin snouts like modern foxes, or short, wide snouts like modern wolves. Although we can't observe dromaeosaurs feeding today, we can look for similar patterns in their snout dimensions. And as it turns out, we do have three distinct groupings of dromaeosaur snout dimensions, ranging from long and shallow all the way up to the short and deep snouts. Now we can look at the evolution of raptors, which are everything that branches to the right of the vertical dashed line. One of the first subgroups within the raptors is the Dromaeosaurinae. These are represented by the largest of the individual eudromaeosaurians, or raptors. The first dromaeosaurian we'll talk about is Dinonicus Anteropus, which possesses a deep and robust snout as well as a highly recurved raptorial claw. Utahraptor, which was larger, possessed a slightly less recurved claw, but was still rounded and probably better suited for gripping. It did, however, have a more shallow jaw, as based on this maxilla from the Utahraptor project. Dromaeosaurus albertensis, found right here in Alberta, has very robust mandibles and a deep maxilla, probably more akin to that like Deinonychus. It did, however, have a raptorial claw that was better suited for the stabbing or slashing like Velociraptor or Sarnotholestinae. Achilobator has a very deep maxilla similar to that of Deinonychus or Dromaeosaurus, but the raptorial claw is not known. All these specimens come from an environment that was rich in fauna and flora, and it was a fluvially influenced environment. These types of environments supported a wide variety of dinosaurs of all sizes, as well as all the vertebrates that supported the dinosaurs. So in terms of raptor evolution, in Dromaeosaurinae, we see two types or two morphologies of claws and 2 types of snouts. So a very diverse and disparate group overall. The next one we'll look at is the Velociraptorine, containing our famous and favorite Velociraptor. The vertically challenged Velociraptorines. Of the first one that we'll look at is Velociraptor Mongoliensis, which has a triangular but still a long and shallow snout relative to the other ones we've talked about, and the highly sickle-like Raptorial Claw that we know and love. A new species of Velociraptor shows an even shallower snout, but having a very similar claw morphology. Atosaurus is a species that we do not know much about the snout, but it has an incredibly reduced claw. So we have a new type of claw morphology that probably didn't serve much use like in other dromaeosaurs. Sagonmangus is a very similar species to Velociraptor, but still contains a long, shallow snout. Although there's no picture of its claw, it was also similar to that of Velociraptor. The environments that these taxa come from are typically more arid and semi to full-on desert-like in terms of their deposition. These environments would not have supported the wide range of dinosaurs of various sizes and would have been restricted to much more small animals like mammals, lizards, and small dinosaurs. So in terms of raptor evolution, the Velociraptorine is known from 2 types of claw morphology, but predominantly 1 type of snout morphology. Next, we'll look at the North American Sarnotholestinae. So these are somewhat stout, but the first Sarnotholestine we'll look at is Achiroraptor temerdiorum. It is known from just a maxilla and a dentary, but reconstructions of the skull would suggest that it has essentially an intermediate snout morphology, not shallow and elongate, but also not deep. Atrociraptor, however, has a very deep maxilla, also known from a maxilla and a dentary, and reconstructions show it being the bulldog of the dromaeosaurs. Bambiraptor feinbergi also has quite the deep snout relative to its skull length, and has a raptorial claw very similar to its close relative Sarnotholestes. Sarnotholestes, as mentioned before, has the long sickle-like raptorial claw, but with a large keratinous sheath covering it shows that it did have quite the recurvature too. These specimens, like the dromaeosaurines, came from very rich environments full of dinosaur fauna of all sizes and shapes, as well as the very small vertebrates. So a very rich and abundant ecosystem. So within the Sarnotholestinae, we have 1 predominant claw morphology with 2 predominant snout morphologies, similar to the dromaeosaurines in those. But which was more influential for raptor evolution? To figure this out, we'll see how many times these different morphologies evolved, and whichever one had more change throughout their evolution was more influential on driving the evolutionary patterns. So we'll start with claws. The ancestor of the raptors had the sickle-like, more slashing claw. So the first change to a more recurved claw was within the Dromaeosaurinae, but it reverted back to the sickle-like claw in Dromaeosaurus. So that's 2 changes. The only other change to report is in Atosaurus, which completely reduced the claw to almost the same as a normal toe claw. So in total, that gives us 3 changes for the claws. But how about the jaws? Ancestry, they started with the intermediate condition, and the first change from this occurred again within the Dromaeosaurinae, moving to a deep snout. This was, however, lost as it reverted to the intermediate snout in Utahraptor, so that creates 2 changes. If we look at Velociraptorinae, we see the 1 change to the elongate snouts, and then within Sarnotholestinae, we have 2 separate changes to the deep snouts in Bambiraptor and Atrociraptor. This gives us a total of 5. So this would suggest that the most influential aspect to the raptor evolution was in fact their snouts, as they adapted to various environments. In summary, we have 3 distinct snout morphologies similar to modern canids, and towards the end Cretaceous we just had 1 predominant claw morphology, the slashing sickle type. The environments varied between these snouts, but generally the intermediate and deep snouts shared a similar variety type, which was very rich in all fauna of all sizes, whereas the long, elongate snouts of the Velociraptorines was more restricted to environments that wouldn't support the large-bodied dinosaurs, so they probably specialized in small prey. This can be summarized by showing these silhouettes of the Velociraptorines, most often going after small prey, the Sarnotholestines and Dromaeosaurines with intermediate snouts going after prey that are smaller and of equal size, and then the deep-snouted individuals which may have gone for prey specimens that actually exceeded their body size. With that, thank you for listening, and I hope you have a wonderful Science Fun Week and that you enjoyed this video.